Okay, so today we're talking about how to prove that lines are parallel. And there's a few different ways to go about this. Today we're going to focus on using our knowledge about our angle pair relationships in order to prove that the lines are parallel. So we're going to use the same thing that we already know, right? Think about this picture that we've been working with. If the lines are parallel, as a result, we know that the alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, and consecutive interior angles are supplementary. We're going to just flip that around and we're going to say, let's use the angle information and decide if the lines are parallel. Remember, if the lines are parallel, alternate interior angles will be congruent. So we're going to test, are the alternate interior angles congruent? If they are, then the lines are parallel. So we're just reversing the way we're doing it. Now we have information about the angles, and we're going to determine about the lines. So we're taking the same four statements, and we're using what's called their converse. We're switching the if and the then. Notice in the picture, the lines are not marked parallel. That's going to be our conclusion. So we're using the same four relationships. If the alternate interior angles are congruent, we test that. Then as a conclusion or as a result, those lines must be parallel. If the alternate exterior angles are congruent, we test it. Yes, the lines are parallel. If the corresponding angles are congruent, then the lines are parallel. And if the consecutive interior angles are supplementary, then those lines are parallel. Same knowledge. That's why we're doing this now. So we're going to verify if the condition is met to determine if the lines are parallel. The second set of examples that we'll look at is we're being asked to force the lines parallel. Very simple. All right, let's do this. So we want to determine if the lines are parallel. So there's 5 different questions. They're all separate from each other. But here's what we're going to do. Notice that in the picture, the lines are not marked as parallel. That's what we're trying to find out. Here's how we do it. We're going to find the angles 1 and 8. So here's 1 and here's 8. Those are exterior angles. Those exterior angles are congruent, which means the lines are parallel. So we can say, since the alternate exterior angles are congruent, then L is parallel to P. So we want to confirm that the angles are what we expect. And then we can say that the lines are parallel. And we're just going to do a few examples. We want to understand that rationale. Angle 3 and angle 6, we'll find them. Those are alternate interior angles. Alternate interior angles are supposed to be congruent, but they're not. Since the alternate interior angles are not congruent, L is not parallel to P. That's our thought process, that's our explanation. When the lines are parallel, alternate interior angles are congruent. Well, these angles are not congruent. So then the lines are not parallel. Sorry. Angle 3 and angle 7. Again, find them. These are corresponding angles. Corresponding angles are congruent. L is parallel to P. The screen is way too jumpy. Let's keep going. 4 and 6. 4 and 6. Those are consecutive interior angles. And they are supplementary. They are supplementary. We can conclude that L is parallel to P. If they were not supplementary, we would say not parallel. And let's see what we have left over here. 3 and 2. So 3 and 2. 3 and 2 are vertical angles. Vertical angles. They are congruent. But that has nothing to do with parallel lines. We didn't even use line P. No conclusion about L and P. We can't say that they're parallel, so we might say that they're not, but we don't have any information. We're not even using line P in that question. Okay. So that's all we're doing is we're doing this backwards. Now, the other thing we could be asked to do, find the value of x so that the lines are parallel. They're asking us to make the lines parallel. Think about that. Find the value of x that makes the lines parallel. If we want the lines to be parallel, this isn't even new. We want the lines to be parallel, so make them parallel and do what you would normally do. We want them to be parallel, so treat them like they're parallel. Corresponding angles. Congruent. So 6x plus 10 equals 2x plus 30. And of course, we can solve for x with no issues. 4x, 20, and x is 5. Again, in these directions, they're telling us, make the lines parallel. Find x so that they are parallel. So go over there, put the arrows on it. They are parallel, and do what you would normally do. 4 and 6. 4 and 6 are consecutive interior angles. Those should be supplementary. So 7x plus 27 plus 4x plus 10 equals 180. And work it out. 37, 180, 11x. 180 minus 37 is 143. And 143 divided by 11 gives us 13. So we're not doing anything different. This is actually exactly the same as the previous lesson. It's understanding the directions. If we understand the directions, we can do whatever we have to do. 2 and 7. 2 and 7. We want to make the lines parallel. So we're going to make the alternate exterior angles congruent. X. And that's it. So proving lines parallel, and again, more than one way to do it, but this is the way we're doing it in this lesson, using the exact same skills of our angle pair relationships. Okay. All right, we'll come back with more.